Okay, here we have a regular hexagon inscribed in a circle. We also have two values labeled. S, the side length of one of the sides of the hexagon, and A, the apothem. Now, the triangle that we have drawn here is made up of two of the circle's radii, which are congruent to each other, and the side length of one of the sides of the hexagon. We know that the area of a triangle is base times height times half. Now, if we substitute in the values that were given, we know that the area of this triangle is equal to side times apothem times half. Now, there are 6 congruent triangles just like the one we have drawn that make up the hexagon. We can draw them if we fill in the other radii of the circle going from the center to the vertices of the hexagon. So, because we know that there are 6 congruent triangles like this in the hexagon, we know that the total area of the hexagon would just be 6 times the area of this one triangle. So, the area of this entire hexagon is equal to 6 times side times apothem times half. We can substitute in perimeter for 6 times side because there are 6 congruent sides making up the perimeter of this hexagon. Then we get that the area of this entire hexagon is equal to perimeter times apothem times half. This is the formula that you can use to find the area of any regular polygon.
Here we have a regular octagon. So each side of the octagon is 10 centimeters. And right now we're going to find the area of the octagon using perimeter and the apothem length. To find the area, we multiply 1/2 times the perimeter, and since there are 8 sides of an octagon, 8 times 10 is 80, the perimeter, and then the apothem length is 12.1. So now we multiply 1/2 times 80 times 12.1 to get the area. 1/2 times 80 is 40, then times 12.1, and you get 484 centimeters squared.
We're going to try to find the area of a regular pentagon with only the perimeter given. So since the perimeter is 40 centimeters, we can find one side length by dividing it by 5. So 40 divided by 5 is 8 centimeters. Now, we're going to use right triangle trigonometry to find out the length of the apothem. So all of the central angles in a polygon must equal 360 degrees. So, and since this is a regular polygon, the central angles must be congruent. So let's say this angle, measure of angle NPM is equal to 360 degrees over 5, since there would be 5 central angles. And that is equal to 72 degrees. Now we know that this big angle is 72 degrees. But we want to use right triangle trigonometry, so we just want this angle. And we know that this apothem bisects the angle and the side. So let's say measure of angle NPQ is equal to 72 over 2, which is 36 degrees. So now we know this is 36 degrees. And since we need one more side to find out the apothem, we can, since this bisects this side, we can say that this is equal to 4 centimeters. Now we can use right triangle trigonometry to find the length of the apothem. So we say tangent 36 degrees is equal to opposite over adjacent, so 4 over length of PQ. Now if you solve this equation, you should get PQ equals 4 over tangent of 36 degrees. If you plug that in a calculator, you get PQ is approximately equal to 5.5 centimeters. So now we have the length of the apothem. Now we can use that to find the area of this polygon. So the area of this polygon is equal to 1/2 times the apothem, which is 5.5, times the perimeter, which is 40. And you should get 110 centimeters squared.
This is an example of a problem where instead of being given the perimeter, you're given the apothem. Because of the central angles theorem, we know that this would be 60, so this would be 30. Then you use right triangle trigonometry, and the tan of 30 is equal to x over 24. If you solve this, with the function, you should get x is equal to 13.86. This gives you this side, but that's only half of this total side. So you have to multiply that by 2, and then you would get 27.72. Then you would multiply this by 6 for all of the sides, and the total perimeter is 166.32. Then you would plug both of these into the formula. You get the area is equal to 1/2 166.32 and multiplied by the apothem, which is 24. If you solve this, you should get 1,995.84. And this is the area.